Hey, this is Kamranu from Agentic. I hope you all are doing great. Guys, this video is going to be very important for you because in this video, we are going to give more power to our AI agent by using the RAG. And at the end of this video, you will be able to learn how RAG is set up in n8n AI agent automation workflow and how RAG works behind the scene. Guys, in this video, I'm going to give you a complete practical knowledge of RAG implementation along with the theoretical knowledge. So without any delay, let's come on the screen. Guys, this is my n8n canvas and this is the AI agent automation workflow for doctor appointment, which I have already built. And now we are going to upgrade the same AI agent automation workflow with the help of RAG. We are going to make it more powerful and more accurate with the help of RAG. So guys, if you want to learn how I built this AI agent automation workflow for the doctor appointment, you can go to my channel's playlist and there you can find the complete n8n tutorial on this automation workflow. You can also download this automation workflow from the video's comment section. I have pasted the link over there. You just click on it, subscribe my channel and download the JSON file of this automation workflow. I'm also going to paste the link of that video in my description box so that you can find easily. So guys, before building the RAG in this AI agent automation, I would like to tell you something about the basic concept of the RAG. So let's go to the slide. Well, why do we use RAG? RAG lets an AI answer the questions using your private documents like business policies, customer record, or internal PDFs without hallucinating. So guys, when we want to give the extra information to AI agent, we use RAG, through which we can upload our documents like business policies, business privacy policy, business terms and conditions, any customer record, or any PDF file which we want to give the AI agent so that it can answer the question of the user. So without this, AI agent can hallucinate because we cannot put all the information in the system message of the AI agent. So that's why we use the RAG system. Secondly, it ensures the AI gives up-to-date 100% accurate answers based strictly on your personal or company data. So by using the RAG, AI agent is supposed to give 100% accurate information to users about our company policy or company data. So the next is, what does RAG stand for? Well, RAG is a combination of three alphabets, R, A, and G. R stands for retrieval, A stands for augmented, G for generation. So when we talk about retrieval, it's searching through your documents to find the exact relevant facts needs to answer a question. So it is supposed to retrieve, extract, or fetch the data from the database so it can look up the proper answer or proper facts to give the answer to user. And the second thing is A, augmented, enhancing, supplementing, or attaching those found facts directly into the AI's prompt memory. So once the facts are found from the database, it attaches those facts with the query, and with the combination of the system message we are using in the AI agent, it makes the answer. And on final step, generation, the AI writing a clear, complete, and natural response using the provided information. So when all the information has been collected from the database, query, and system message, then it is supposed to generate the answer. So to understand it in a more perfect way, we use this example. Think of RAG like giving an AI an open book exam, like retrieval, where AI agent fetches the exact facts from your database, augmented, attach those facts into the prompt, and generation lets the LLM write a smart, accurate answer. So in this example, we are giving the AI agent a book or database from where it is supposed to collect or extract the answer or facts, and then it write a smart, accurate answer. So the next is, well, there are many types of RAG. Here you can see RAG types. There are many types. Here are the strengths of the RAG and ideal use according to the business need. So guys, this is my first video on the RAG. So I'm not going to go deep dive in the RAG types. So simply in this video, I'm going to discuss the first RAG type, which is naive basic RAG. In later video, we will cover all the types of the RAGs. So the next is RAG data flow, which is the RAG pipeline. And here we can see how we can build the RAG and what are the steps to build the RAG. So you can see here there are two portions or two sections. So the first one from step 1 to step 6 is also known as data ingestion or indexing, and the second one is also known as retrieval and generation. So in data ingestion, we give the data in the shape of these files, and after passing the few steps, we store our data into the vector database. And in second section, which is also known as retrieval and generation, here AI agent use the user's question and then retrieve the data from the vector database and generate the answer. So now I'm going to discuss all the steps one by one in a very easy language with easy words. So in the first step, we upload the file. We can upload file from the PDF, Word, Excel, PPT, etc. And on the second step, we get the data extraction in the raw text form from the file. Like you can see, this is raw text written here. And the third step is you can see text chunking, split text into smaller manageable chunks. So when we give the entire document, which can have 10 pages, 20 pages, 50 pages, 100 pages, 500 pages. So in order to manage the entire text, we split the entire text into chunks so that it can be manageable in order to store in the vector database through the embedding model. So you can see here chunk number 1, minimum 0 to 500 words tokens. We can say chunk 2, 500, 1 to 1000. So these are the process of chunking. And once it is chunked, so guys, on the fourth step, embedding model convert each chunk into vector embedding. You can see here, these are the vectors. So the text is being converted into the vectors. So what is vector form? It is simply the mathematical numerical representation of data. So when the data is to be extracted from the file, it is chunked, and the embedding model is converting all the raw text into the vector embeddings or in the mathematical number form. So this raw text is unstructured data, and this is the structured data for computer. So in the next slide, I will tell you further about this. So embedding model is converting the data into the vectors, and these are the embedding models we can use in n8n, like OpenAI, Cohere, Hugging Face, Google Gemini, and there are a lot of models we can use as per the requirement. So the next step is metadata creation. After the vector embedding model gives the label to each chunk. Like you can see, source hospital policy PDF, chunk ID 1, chunk number 1, page number 3, and the section appointment policy created on this date. So metadata helps for the better search and better filtering the facts or the answer from the vector database. So finally, the sixth step, which is storage of the data in vector database. You can see here, store embedding plus metadata in vector database. So in vector database, the data is stored in the vector form with the metadata, or we can say it with the labeling of data. So here we can use multiple platforms like Quadrant, Pinecone, Viviet, Chroma, and Supabase. So these are the 6 steps through which data ingestion is performed. Now let's talk about the second section or the second step, which is the user question. You can see here, user ask a question like, what is the hospital appointment reschedule policy? So when user sends a query, again embedding model converts that query into the vector embedding, because computer understand the data in vectors form. So here we can see the query is also being converted into the vector form by the embedding model. After converting it into the vector form, there is a step of similarity search. You can see here, search vector database for relevant chunks. So if the query consists of these numbers and the answer also have the similar to these numbers, which is already stored in the vector database, then on the basis of similarity check or semantic meaning, it finds the data, it extracts this data and prepare the answer. So I will tell you more about in the second slide with an example. So the next step is retrieve content. You can see here, fetch text plus metadata of top chunks. So after the similarity chunk, it retrieved the data with the context. And then on step number 11, augment and generate. Send question plus context to LLM for answer. So after retrieving the context and data from the vector database, it sends the question and retrieved data from the vector database to LLM or chat model like OpenAI, Claude, Gemini, whatever we are using in our workflow automation. So after having all these things, LLM generate the accurate and proper answer. So hopefully you get it a little bit, but for your more better understanding, I'm going to share this slide, how RAG data flow works. So when we set up the RAG in n8n, first we have to download the file with the Google Drive node or whatever the source you can use and whatever the format of file you can use. But in my case, I'm using the PDF file and Google Drive node to extract the data from my Google Drive. When we extract the data on the first step, it is unstructured data. As I have already told you, that this is unstructured data for computer. Like on this step, this is raw text. The computer cannot understand the raw text. The human only can see and understand this text. So in order to make this raw text or unstructured data into the structured data, we use this whole process where we are supposed to use data loader node in n8n, which extracts the data from PDF file into the text form and creates the text into manageable chunks. So here data loader node is supposed to do the text chunking, and then we add the embedding model like OpenAI, Gemini to convert the unstructured data into embedding vector, like in numerical mathematical representation form for computer requirement. So our vector database is asking for the raw text into the vector embedding form or mathematical numerical representation form, so that it can be stored in the vector database. So after when we successfully do the embedding vectors, it is able to store in the vector database. So the next slide, here I would like to share you a further deep dive about vector embedding. A vector embedding converts data like words, sentence, or images into a list of numbers. Guys, I have written this in a very simple language so that you can understand it, rather than to go more deep dive into the technical terms, as it is very technical thing. So I would try my level best to make you understand with the simple and easy words. So again, a vector embedding converts data like words, sentences, or images into a list of numbers. You can see this is a word like cat, and this is the list of numbers. So here may be an image, video, sentence. A vector embedding is supposed to convert these text, images, sentences into the numerical representation or list of numbers. So it's create a long list of number, and these vectors have multiple dimensions. These number represents the meaning of the data. So we have converted the word into the number, but these numbers actually represents the meaning of the data, which computer can understand. So when we store these numbers in a vector database, you can see here, this is the vector database or vector store or space we have got from any of the platform like Supabase, Quadrant, Pinecone, and it is a multi-dimensional space. It's look like a box where it has many data nodes, a data point. You can see here, these are the data point. Data with similar meaning are placed close to each other. You can see here, this is the example of fruity category like banana, apple. So these are the vectors with the similar meanings. Similar meanings like they are falling into the fruity category. So they are sitting with close to each other. And similarly in the animals category, you can see here, there is a wolf, dog, tiger, lion, cat, cheetah, kitten, cat. So these category is sitting with close to each other. So how they are sitting very close to each other, I will tell you in the next slide. So right now I think this is enough, not to go more technical terms. The last sentence I would like to share. This allows computers to search for information based on meaning, not just exact keyword. For example, in our document, there is a word cat, but not kitten. But when user asks the query regarding the kitten, LLM will find the similarity chunk into the vector database, then it will prepare the answer. How? I tell you. Embedding models are trained to represent the meaning of words and sentence. Embedding models are trained. So embedding models are trained in a way that it can represent the meaning of words and sentences as vectors, because related concepts such as kitten and cat have similar vector representations. So when a text or sentence is being embedded in a vector form, it gives the semantic meanings of that particular word as well. So we don't need to find anything with exact keyword. Like because related concepts such as kitten and cat have similar vector representations, a RAG system can retrieve information about cats even when the user asks about kittens. The LLM then uses the retrieved information to generate the answer. So simple example, you can see here how kitten finds information about cat. RAG finds meaning, not just exact words. Like this is the information which is kept in the database. Cats are small domestic animals. Then embedding model is converting this text into the vector form or numbers form. You can see a vector for cat information, and then it is stored in the vector database. But during the storage, it has the similar meaning, stay close in this space. So when the query comes from the user, what should I feed my kittens? You can see here it's not talking about the cat, it's talking about the kitten. But here, when the query is again converted into the embedding model, so it generates the vectors which are almost similar, which has almost similar meaning with the cat, and then the information is sent to vector database for similarity check. You can see here the query is kitten and it goes to the cat category or animal category where it finds the cat because it has the similar vectors. So kitten vector is close to cat vector. So it is selected. Then relevant information retrieved. And when the relative information is retrieved, then LLM gives the answer. You can see here, LLM generate answer. User question, what should I feed my kitten? Retrieved information, cats are small domestic animals. LLM answer, you can feed your kitten high quality cat food that is rich in protein and nutrients. Then LLM gives the answer to the user, and in this way it works. So hopefully you got the basic concept of the RAG. So guys, now this is the time to build RAG in the n8n. So let's go to the n8n canvas. Here first I'm going to extract the document from the Google Drive. So I'm going to use Google Drive here with download operation. So guys, here I have already set up the credential. And if you don't know how to integrate the Google Drive, Google Sheet, Google Calendar in n8n, then I have already uploaded the video in which I have showed how to integrate Google Workspace through Google Console API. So the operation is download, and here I have already uploaded the document on my Google Drive. So I'm going to download the file by selecting the exact file name. This is Hospital Policy Manual. Now I'm going to execute it. Well, the file has been extracted. Just close this. I'm keeping this node here. Guys, now we have to add the vector database first, because as per data flow, you can see here the vector database is placed in the last, but these two nodes are connected inside the vector database. So that's why we are connecting the vector database first. I'm writing here Supabase. You can see here Supabase vector store. You can use other vector store as well as per the requirement, but I am going to use Supabase. So here the operation will be add documents to vector store. Just like this. Here first we have to select the credentials, and right now I didn't set up the credential, and now I'm going to set up the credential first. Just click on set up credential. Here you can see the requirement. We need a host and service role secret. So in order to getting these two values, I'm going to my Supabase account, Supabase. Here I have created only my organization, and if you are fresh on this page, you first have to create a new organization, which is very easy to create. So I'm going to select my organization, and here I have to create a project first. So now I'm going to select new project. This is my organization name, this is project name. I'm going to give it, any of the name can be given to it, n8n. Here we need to give the password. You have to generate a new password. Just copy this password because we need it in later step, and also save it anywhere like in a notepad. Well, I have saved it, and then click on the create new project. I'm going to save it. Well, the new project has been created. Now we are going to get host URL. Click on integrations, data API. Here you can see API URL. Just copy this and paste. Yep. Just remove these two endpoints till the co. Now the service role secret, go into the project settings on the left corner, and here click on API keys, and here you have to find the service roles. I will get it from legacy and on service role play keys. Here is service role secret. Just click on reveal, copy and paste here. Click on save. Now we can see it is green or not. Well, you can see connection tested successfully. Operation is insert document. Now we have to select the table name. This is important. So when I click on drop down, you can see there is no result. So first we have to create the table in the data store. So in order to create the data store, we will navigate to a document. Just click on pencil icon. Here you can see read our documents. Just click on this. Here you will find this is the page of Supabase credentials. Just click on Supabase vector store. Scroll down. And here quick start for setting up your vector store. Click over there. Well, in this new page, we have to use this snippet SQL, you can see here, prepare your database with the relevant tables. So just copy this and go to your Supabase. Here we need to create a store. On the left side panel, you can see SQL editor. Click on this and here paste this snippet and click on run. You can select here run without RLS. It's running and you can see success. So now you can see vector database has been created in Supabase. We can check it from over here, table editor. In the left side you can see the documents. This is the table has been created in the Supabase, and now I'm going to find this table in the annotate node. Just refresh this, click on drop down. You can see the table has been reflected here with the name document. I'm going to select this. So here you can see embedding batch size. This is the batch size through which annotations can send the total chunks to embedding model on one API call. So because my PDF file is so small, consisting only on 7 pages, so I can select 200 or I can select 50 even. So it's the embedding batch size which annotation determine how much chunks is to send to embedding model in one go. So now its parameter setting is finished. We cannot execute step right now because we have to add data uploader node and embedding model here. Here we will add the data loader. You can see default data loader. Select this one, and this node is supposed to do the text chunking. So here we need to do some settings. Type of data, this is binary. This is kind of binary type data. So we are going to select binary. Mode, keep it as it is. Data format, automatically detect by MIMI type. Text splitting, simple. Option, there is nothing special right now to select. So this is done, close. Now we are going to add embedding model. So you can see here a lot of embedding models are here. You can select as per your requirement. So here you can see embedding OpenAI model. So you can use this model if you have the paid API key, but because I don't have the subscription of this OpenAI, so I'm not going to use this. I'm going to use Google Gemini model. You can see here I have the free key. Simple API key can be used here. You just need to insert the API key here. Here we need to select the model. I'm going to use this model. But guys, here is one more important thing which you need to remember. You can see here the default model is using 768 dimensional embedding, and the store we have created here, I would like to show you SQL editor. You can see here 1536 dimensions. The snippet I have copied from the LangChain SQL. It gave me the snippet with vector 1536, but this model allows me 768 dimensional embeddings. So here OpenAI works perfectly with 1536 dimensions, but because I am using embedding Google Gemini model and it is using here 768 dimensions, so I have to create the store with the exact requirement. So now I'm going to change the store settings. This is the store I have created in Supabase, and now I'm going to delete this. I can delete it from here. Delete table. Delete. Well, the table has been deleted. And now I'm going to create new store, discard, as per the Google Gemini embedding model. So I have to paste here the different snippet which is compatible with Gemini embedding model. Paste, save, run without RLS. Success. Click on table editor. The table has been added with the name documents, and in Supabase vector store I'm going to refresh it again because I have changed the table as per the embedding model with new snippet. So if you are using OpenAI, you don't need to do this step. I was just wanting to show you how you can copy the snippet from this document using the OpenAPI embedding model. So now it is completed and ready to run. The PDF file has been extracted. So before execution, I would like to show you something in the Supabase. You can see here, click on document. There are the columns of table, but all are empty. And when our data will be stored in the vector base, it will show you all the data here. So now I'm going to execute this. Execute, run. It is chunking. Well, you can see it is successfully completed the task, and 20 items or 20 chunks are stored in the vector database. Now we can see in Supabase. Just refresh it. Reload. Well, nice. You can see the data has been uploaded in the vector store, and here you can see metadata, serial number, 20 chunks. This is the content in raw text form. I can show you. In this form, it has been saved. and these are the metadata labeled each chunk so that it can search and extract in a correct form in a perfect way. So you can see here hospital name and policy and procedure manual is labeled in metadata, and this is the embedding vectors. You can see the list of numbers where it can also find the similarity vectors. This is the array. Each vector has a mathematical numerical representation of data with numbers array, and now our vector database is ready to give the users query answer. So guys, our first step of data ingestion has been completed as per slide. You can see here the sixth step we have completed, and now we are going to set up the retrieval and generation steps in n8n. As you can see here, our vector database is ready for retrieval the data which is used by the AI agent. So now we are going to give the access of our vector database to AI agent. Vector database is going to be used as a tool for AI agent, and here we will search again Supabase vector store. You can see here Supabase tool for AI agent. Here you can see Supabase vector store, just like this one. The credentials will be remain same which we have used while creating the Supabase vector store account. The operation will be this one, retrieve document as tool for AI agent, and in description we are going to tell the AI agent call this tool to look up hospital policy manual, the document which I stored in vector database. Now I'm going to select my table from this list, the same table we have created in the Supabase here with the name of documents where all the data is lying. Documents limit you can keep it on 4 by default, and there is nothing special more to do. Just close this. Guys, now you can see here the AI agent has two tools, one for patient data which I already have given the AI agent, and the second tool is which is used to give the extra information which is not mentioned or cannot be mentioned in the system message of AI agent. So guys, one thing is more here, how RAG works. As you can see in this slide, when the user question to AI agent, the query goes to the embedding model, and query also convert into the vectors, and then that specific vector goes to the vector database for similarity check, for similarity search. So the same thing we are going to do here. We are going to connect this tool with the embedding model which is used in this pipeline. So when the query comes, the AI agent can send the query to the embedding model to convert it in the vector form. So guys, the next thing we are using here simple memory. We can also use the Postgres chat memory. So I'm going to remove this, and I'm going to use the product of Supabase Postgres chat memory. There is no credentials are set up. So first we have to set up the credential. Just click on this. Here we have to give some credentials. So I'm going to navigate again on Supabase. Here on the top, just click on connect. Select direct connection string. And here we need to find the transaction pooler. Click on transaction pooler and scroll down. You can see this connection parameters. Just copy this host, paste here. Then port. Here in the port, the same port must be here. Now the database is Postgres. It's okay, the same. And the user, copy this and paste in the user. And for the password, it will be the same which we have saved in start during creating the project in the Supabase. So I'm going to paste that password. So guys, now all is set up. Click on save. And we can see here, if it is green, connection tested successfully. So we have given our AI agent the memory using the Postgres account. So I'm going to map this defined below. And now I'm going to give it a session key. So guys, now I'm going to test this AI agent automation workflow using the RAG. And I'm going to publish this workflow. Publish. I'm going to navigate on my WhatsApp. And here I'm going to ask a question regarding hospital manual policy. Well, I write this question. How much will a consultation with Dr. Kamran Noor cost? And what is the fee if I come back in 5 days with my ECG and echo reports? Send. Well, I got this answer. A consultation with Dr. Kamran Noor cost rupees 2000. If you come back within 7 days with for example, in 5 days with your ECG and echo reports for a review, the follow-ups visit fee will be rupees 1000. So guys, it has fetched the data from data store vector database on the basis of this document. You can see here it picked the data from over here. Consultation fee 2000, and follow-up visit within 7 days is rupees 1000. So now I'm going to test it with this question, like what is the payment method? What will be the payment method if I book a new appointment? Send. Well, we have received the message. Park International Hospital offer multiple convenient payment channels on site: credit card, debit card, Visa card, mobile wallet, and bank transfer. You can see here the same information it has given us, which is stored in the vector database. And now I'm going to ask third question regarding detailed payment refund policy. If I want to cancel my appointment, then what is your refund policy? If I want to cancel my appointment, then what is your refund policy? Send. So guys, you can see the response of the AI agent. If you cancel your appointment at least 2 hours before the scheduled slot, you are eligible for a 100% full refund. So guys, as you can see the answer, it is same as which we have mentioned in our data policy document with payment refund policy. So our AI agent is working perfectly using the RAG. And in Supabase, we can see here our chat history is being stored. So this is my mobile number, which is being used as session ID. And these are the messages which are stored in Postgres chat memory. We can also use the simple memory here, but on production level, this is good to go. So guys, hope you like this automation workflow and this video. And please must subscribe my channel so that you can get more videos like this. Thank you very much.